Hi there. Today we are going to see about the precision clipper circuits. First of all, we need to know what are clipper circuits. Clippers, from the name itself, it's going to clip something. What is going to clip? When we apply a sine wave on a clipper circuit, it will clip the unwanted portion. Either if you want to clip the positive portion of the applied sine wave, it is called positive clipper, or if you want to clip the negative portion of the applied input sine wave, it's called negative clipper. It is a wave shaping circuit which controls the shape of the output wave by removing a portion of applied wave. It has the clipper circuit's ability to clip a portion of the input waveform without distorting. And then let's see the types of the clippers. Clippers are classified into two types, positive clippers and negative clippers. Positive and negative both clippers are classified as two types, positive series clipper, positive shunt clipper, negative series clipper and negative shunt clipper. First of all, we go to see positive series clipper. In this positive series clipper circuit, the diode is connected in series with the load. The diode's anode is connected to the negative terminal and the cathode is connected to the positive terminal. Now the diode is in the reverse bias condition. When we apply the sine wave to this positive series clipper circuit, in the positive half cycle, the diode doesn't conduct because the diode is in the reverse bias condition, so it acts as an open circuit. So there is no output in the positive half cycle. But when the applied sine wave reaches negative half cycle, the diode terminal has been changed. The anode connected to the positive and the cathode connected to the negative. Now the diode in the forward bias condition. Now it's act as a closed circuit. Now we get the output waveform as the negative portions only. In this clipper, the positive portion of the applied sine wave is removed. This is called positive series clipper. Next, we move on to the positive shunt clipper. This positive shunt clipper, the diode is connected across to the load. DPQ load. In this positive shunt clipper, the diode is connected across the load as I said. The diode's anode is connected to the positive terminal and the cathode is connected to the negative terminal. Now this diode in the forward bias condition. If we apply the input signal to the positive shunt clipper, in the positive half cycle the diode conducts because the diode in the forward bias condition, so it acts as a closed switch, but it doesn't allow the output to the load because the circuit is closer to this area. Next, when it reaches the negative half cycle, it acts as an open circuit. So the diode is in the reverse bias condition, so it doesn't conduct. Therefore, whatever signal applied in the input, that will appear across the output. Let's see the output of the positive shunt clipper. This is the input signal and this is the output. In positive half cycle, there is closed condition, so there is no output in the positive half cycle, but in the negative half cycle, whatever the signal applied to the input of the clipper, that will appear across the output. This is the output of the positive shunt clipper. Then we go to the next clipper, negative series clipper. In negative clipper, we are going to clip the negative portion of the applied input. In this clipper, we are changing the diode position. The diode's anode is connected to the positive terminal and the diode's cathode is connected to the negative terminal. Now it acts as a closed switch when we apply the signal. So let's see. When we apply the sine wave to this negative series clipper circuit, when in the positive cycle the diode starts to connect because the diode in the forward bias, so it's closed, act as a closed circuit. In positive cycle, the diode conducts, so we get the output waveform. When it reaches the negative half cycle, the diodes anode get negative and diodes cathode get positive. So now the diodes get in the reverse bias condition and act as a open circuit. So there is no output in the negative half cycle. So this is called negative series clipper, which clips the negative portion of the applied input signal. Next, we see the negative shunt clipper. In this clipper, the diode is connected in series with the across to the load with series and resistant. In the negative shunt clipper, diode's cathode is connected to the positive terminal and the anode is connected to the negative terminal. So now the diode in the reverse bias condition. Now if we apply the sine wave to this negative shunt clipper circuit, when in the positive cycle the diode doesn't connect because the diode in the reverse bias condition. We know that in shunt clippers it allows the input signal to the output when the diode in the reverse bias condition, so we can get the complete positive half cycle as the output like this, right? We can get complete half cycle, positive half cycle as the output. But when it goes to the negative half cycle, the diode starts to conduct in forward bias condition, so there is no waveform in the output. It completely blocks the output like this, so we can get only the positive half cycle as the output. It is also known as half-wave rectifier. Okay, next we go to our topic, positive precision clippers. Why precision clippers? The normal clippers can be used for the low voltage signal, but the precision clippers can be used for low voltage signal by using the op-amp. The both positive and negative precision clippers are works in the condition of when the input value and the reference value. That is, in this clipper circuits, the waveform is clipped depend upon the reference value and the input value. Let's see to the positive precision clipper. While we apply a sine wave to this precision positive clipper circuit, in the positive half cycle, the input value is greater than the reference value. So the diode is get reverse biased. So it acts as an open circuit. So there is no waveform. But in the reference, we can get the reference value 0 or 1 at in the waveform. When the applied input waveform goes to the negative half cycle, the input is lesser than the reference value. So now the diode in the forward bias condition, it starts to conduct and we can get the output like this. So this is the reference value and this is the negative half cycle. In the positive precision clipper, it clips the waveform depend upon the reference value and the input value. If the reference value is greater than the input value, it will be clipped. Sorry for the pronunciation. The input value should be less than the reference value in the positive precision clipper. Now let's move on to the next type of the precision clipper. This is the negative precision clipper. From the name itself, it's going to clip the negative side of the input signal. The condition for the negative precision clipper is when the input value is greater than the reference value, it clips the particular region. If we apply the sine wave into the negative precision clipper circuit, when in the positive half cycle, the input value is greater than the reference value, so the diode conducts because the diode in the forward bias condition. So the diode's position also changed like this. So we can get the output waveform like this. When the input signal reaches a negative off cycle, the input value is lesser than the reference value. The condition for the negative precision clipper is the input value should be greater than the reference value. So the diode doesn't conduct, it goes to the reverse bias conditions. So we can see it comes up to the reference value of 1 or 0. 1, I think 1. In the negative precision clipper, the condition is the input value should be greater than the reference value. So thank you for watching. I hope you can understand what I try to say. Thank you.